exercises in the back of the distance formula and equation of a circle notes. All right. So we're going to start question 1 here. All right, so before we get started, we need to know 2 formulae. All right, we are going to need to know the distance formula, and the distance formula says the distance between any 2 points on the Cartesian plane are, well, we just take the coordinates, x1, and we take away that from x2, and we square it, and y2, take away y1 squared, and this is derived from the Pythagorean theorem. And then we have the circle formula. This is the general formula for the equation of a circle. And this says that we're going to take a general value x and take it away from a specific x value, which we're going to call x naught squared, plus y, take away y naught squared, and that's equal to the square of the radius. And you can see there are similarities between these two equations. If we squared this side, it's going to look an awful lot like this reaction if we substitute, pardon me, I said reaction twice, this equation. But they're going to look similar provided we substitute the distance between 2 points for the radius, which is the distance from the center to the edge points. So actually, a circle is defined to be the shape that you get when you measure a fixed radius from a specific point, which the coordinates x naught, y naught. That's the coordinates of the center point, and if you just measure all the points that are 1 radius away, then we get a circle. And that's how the distance formula, the distance is from here to here, that's the radius, relates to our circle formula. Okay, so those formulae are going to be necessary for us to proceed, and we're going to have to just decide which is relevant. So for question 1, we're asked to determine the distance between 2 points. All right, so I think just to model good form, I'm going to use the formula for this, but before I do that, I'm going to sketch these 2 points in space. All right, so that's the point 3, 6. 1, 2, 3, 1, 2, 3, 4, 5, 6. I like to make my 5s a little bigger. Okay, and that's the point 3, 6, and the origin 0, 0. Okay, so to model that, I can make a Pythagorean theorem right triangle. And this will have a height of 6, and this will have a length of 3. Okay, and so that's what's going on here. However, I think I'm going to use my formula, so I'm going to say my point 3, 6 is going to correspond to the value. I'm going to call this point 1 here, so 0, 0 is going to be x1, y1, and this will be x2, y2. Okay, so I'm going to rewrite this formula for the distance. This is A. So the distance between these 2 points, d, is going to be the square root of x2, which is 3, take away x1, which is 0, squared, plus the y2 value, which is 6, take away our y1, which is 0, and that's all squared. And this is all a way of finding that the distance along these edges, or legs, of the right triangle are 3 and 6. And then using the Pythagorean theorem, we would then square both these values, add them together, and then square root them. And that's really what the distance formula says. It's just a all rearranged previously form of the Pythagorean theorem. And so it says that we're really going to get the square root of 9 plus 36. And so that says the distance is the square root of 45. Now, it's worth mentioning that the square root of 45 can be simplified. I should just focus that a little bit. the square root of 45. That still doesn't focus very well. Maybe I'll just zoom in a little bit. Now it'll focus. The square root of 45 can be simplified. So I will run through my perfect squares here. Oops. Okay. I like to run through my first few perfect squares. So, for example, 1, 4, 9, 16, 25, 36, so on. And I just check to see which is the biggest one that goes into 45. And 9, of course, goes into 45. 45 is just another way of saying 9 times 5. And that's the same thing as saying the square root of 9 times the square root of 5, right? We learned that last year in grade 11. Okay, well, what's the square root of 9? Well, the square root of 9 is 3. So the distance is really 3 times the square root of 5. And that's how far it is between these 2 points. 3 root 5. Now that has a decimal approximation. It's probably something a little bit bigger than 6, because 5 is a little bit bigger than 2, or the square root of 5 is somewhat bigger than 2. We can actually find a value for that, 3 root 5, it is 6.7, or 8, however, we prefer a simplified radical as our answer. All right, so we're going to move on to question 1b. Now, before I get started, I am going to just draw out this coordinate. So that's at the point negative 3, 6, negative 3, and 1, 2, 3, 4, 5, 6. Oh, no, that's negative 6. Sorry. And this is 1, 2, 3, 4, 5, 6. That's point 6. All right, so we got this point here, and it's at negative 3, 6. All right, and if I draw a little triangle here, I'm really finding the distance between the origin and this point. However, I may notice that this diagram looks very similar to this one. I have a triangle right, the side of 3 here between 0 and negative 3, and a side of 6 between 0 and 6 here. This is the same triangle. It's going to have the same length of the hypotenuse. Now, if that's true, then if I put in, I will make my x1 and my y1 0, 0. If I make my x1 negative 3 and my my x2 and y2 negative 3 and 6, I should get the same answer despite the fact that I'm throwing negatives in my formula. So that seems a little funny. So I'm just going to test that to make sure it's true, because my intuition tells me it should be the same. But also I have a conflicting intuition which tells me that when I put a negative into a function, it should do something different than if I put a positive number in. So I'm just going to go there and make sure. So I'm going to find a square root. My x2 is now negative 3. My x1 is still 0, so I'm going to take away 0. I'm going to square it. And I'm going to take away my y2, which is 6. Take away y1 of 0. I encourage you to label your x2s, y2s, x1s, and y1s between your points. All right, now let's see what happens here. So we've got the distance is equal to the square root of, so that's going to be negative 3 squared plus 6 squared. Now, how does that compare to this stage in this question? Well, it looks like the inclusion of a negative makes this a negative 3 instead of a 3. But when I square negative 3, I'm going to get the same answer as if I squared 3. So my next line, even though I had a negative in there, ends up meeting with the work of this question somewhere along the line at this stage. At this stage, we're going to repeat all of the rest of the work because we found that we're able to get rid of that negative somehow. And our intuition, which said that these two triangles are really the same, they're just shifted, works out. So we get the square root of 45, and I get 3 root 5. It's the same answer. All right. So I'm going to move on to question C. And question C looks similar again. So I'm just going to draw that point out. That's the point. 1, 2, 3. 1, 2, 3, 4, 5, 6. And there's the point 3, -6. And the point 0, 0. Now again, I notice I get a really similar triangle. It's 6 units long here, and that's 3 units long here, and I'm looking for the distance. I think here we've seen enough tricks to recognize this is actually going to be the exact same triangle. So the distance is going to be 3√5. And if you are unconvinced by that, I would encourage you to go through the steps of this formula. You should get 3√5 as a result. And if you do not, please let me know, because that means we have to figure out where things are going wrong. And lastly, I have an intuition this is going to be the same answer, but let's just sketch it out anyway. So we have a good picture in our mind about where this point is. We've got a point 1, 2, 3, -3 here. And -1, 2, 3, 4, 5, 6, -6. All right, we're going to get that point here, -3 and -6. And we're looking for the point between there and the origin. And indeed, we do get the same triangle with a length of 6, 3, and we're looking for that diameter, so, pardon me, distance. So we can say the distance is 3√5, just like it was before. All right. Okay, let's move on to question 2. So we're looking for the distance between the points 1, 4 and 7, 2. So I'll write the points down. Points 1, 4 and 7, 2. So I could sketch these points out, and maybe I will. Okay. So that means I'm looking for distance between the point 1 and 1, 2, 3, 4, and the point 1, 2, 3, 4, 5, 6, 7, and 2. So I get this point here. That's my point 1, 4, and my point 7, 2. So they look like they're pretty close. They look like they're in the right quadrant, same quadrant. They're going to make, I can make a 1, 4, okay. So I can make a little right triangle here as well if I like to picture what I'm doing. But I think I'm going to leave it there. I'm going to let the formula do the heavy lifting for me this time. I'm going to trust that the formula works. Now I'm going to look here and visually inspect and say, I expect my answer to be somewhat similar to 7-ish, somewhere in that neighborhood. It shouldn't be 100, and it shouldn't be -5, and it shouldn't be 0.1. Something like 7-ish, maybe 8, maybe 6, but somewhere in that neighborhood. So I'm going to let that be my check. If my value is somewhere in that neighborhood, then I'm going to assume I'm correct. All right. So I think a good thing to do is to label each of these guys. So I'm going to make this point 1 and that point 2. That's arbitrary. You can switch that, and you will get the same value. And so x1, y1, because it's point 1, and this is x2 and y2. Okay. So our formula says we're going to take x2 and we're going to put in our formula, and we're going to take x1 away from it. So our x2 is 7, and we're going to take away our x1, which is 1. And then we're going to add to that, y2, take away y1, this difference between y2 and y1. y2, which is 2, take away y1, which is 4. Okay. And so then we get the square root of 7 take away 1 is 6 squared, plus 2 take away 4 is -2 squared. So what we've just done is we've found two distances of this triangle. In case you were wondering what this has to do with a triangle, we found that we have a distance of 2 here. It ended up being negative, and that's because we chose this one be 2 instead of this one. But that comes out in the wash because we're going to square things. And we found a distance here of this part of the triangle, this leg, to be 6, which is the value between 1 and 7. 1 and 7. Okay, so there's some semblance of reality here. We're not just doing black magic. We are really recreating this triangle. All right. Okay, so that's the same thing as saying 36 plus 4, which says I've got a distance of square root of 40. And again, I should probably look at any of my perfect squares. They go into the number 40. And the biggest one is the number 4. So actually, d could be rewritten, the distance could be written as 4 times 10, because 40 is a square, pardon me, the 40 is the same thing as 4 times 10. All right, so that means I could really rewrite that as the square root of 4 times the square root of 10, or really just say the distance is 2 root 10. And that is question A. All right. So for question B, 2B, I am going to try to let only the formula do the work. I'm going to trust that the distance formula is going to give me the right answer without drawing a diagram. I'm just going to trust that it does. And enough mileage with the distance formula, you're going to feel like you can trust it, and you can, because you derived it from the Pythagorean theorem. All right, so I'm going to say, what do we have? The points -5, 3, and we have the point 5, -1. So I'm going to say I'll let this be, I meant let the first point be 1. I'll make this one 2 this time just to switch it up, just to emphasize it doesn't really matter. And I'll make this point 1, so that means I'll make this x2 and that y2. And this will be x1 and y1. Okay, so I'm going to rewrite this formula. I'm going to rewrite it over here. And I'll say, okay, that means my distance is the square root of x2, -5. Take away x1, which is 5. And we'll square that. And then we'll add y2, which is 3. Take away y1, which is -1. So we're going to take away -1, which is the same thing as adding 1. And we're going to square that. And so that tells me a square root of -10, all squared, plus 4 squared, which is 100 plus 16, or really the distance is square root of 116. So again, I might take a second to wonder, can any of my perfect squares go into 116? 6 times 6 is 36, 7 times 7 is 49, 8 times 8 is 64, and it doesn't look like more than 164 can go into this, so I think that's probably where we'll stop. Alright, so 64 is out because 2 64s is 128. It's already too big. 49, this doesn't look close to counting by 50s. So if it doesn't look, so if it was closer to 147 or something like that, and then maybe I would ask or wonder about 49, but I think that's out. 36, maybe. I'm not sure. Actually, I'll need to think about that. I'll put a question mark next to it. 25, well, it's not a multiple 25. I can't get there by adding quarters and get 116 cents. 16, well, I don't think so, because 16 is not a factor of 100. So, and then I'd have one more 16 after 100 to get 116, so that's out. 9, if I add up 1 plus 1 plus 6, I get the value 8, not 9, and so it's not divisible by 9, so 9's out. 4, maybe, and 1, obviously. But 1 is what we call the degenerate case. All right, cool. So let's start with 36. So if I multiply 36 and 36, I get 72. And And then I got another 36. I get 108. Well, this isn't looking good. Okay, because another 36 is 144. Okay, so 36 seems to skip over, so we're wrong there. Is it divisible by 4? Well, it's divisible by 4 if it's divisible by 2 twice. So if I can write 116 as 2 times 58, and then I'll split 58 into 2 and 29. So I can divide it by 2 twice. So it can be actually written as 4 times 29, which can be really written as the 2 root 29, which is our simplest possible answer for the distance between these two. Okay, let's move on. So we're going to give the equation of a circle with the given properties. I think this is actually going to go pretty quickly. So 3. All right, so our center is the origin. So our formula is x take away x naught plus y take away y naught squared. That's equal to the square of the radius. Oops. And so in this case, our x naught and y naught are 0 and 0 because these are the coordinates of the origin. Oops, I forgot to square that. Y take away 0, and the radius is 2, so we're going to have 2 squared. Now, if I have x take away 0, well, that's x squared, and y take away 0 is just y, so I'll have y squared, and that's equal to, well, 2 squared is 4. And that's the equation of our circle that has a center at the origin with a radius of 2. Okay, so next we have a center at 2, 3. And a radius of 7. Okay, so the center at 2, 3. So that'll become our x naught and our y naught. All right, so then we're going to rewrite our formula from up here. We're going to write it as x take away x naught, which is 2, squared, plus y take away our y naught, which is 3, squared, and is equal to our radius, which is 7 squared, which I'm going to just call 49. All right, and that's our final answer. You could expand this if you like. It is not necessary. This is a sufficient form for a circle. And we're going to see as we expand and look at other conic sections, like a parabola or an ellipse, maybe even a hyperbola, we're going to see how these are all sort of, they find similar forms for expressing themselves. Okay, so, and it's only when we keep this unsimplified form, or unexpanded form, that we can really see those similarities. So that's why we're going to keep it there, rather than continue to simplify it ad nauseam. All right, question C says we have a circle with a center of 5, 6. So for C, I'm going to point at, -5, -6, pardon me. So x naught and y naught, and a radius of 8. So our radius is 8. And so that means we're going to have, using our formula up here, x, take away our x naught is -5, so we're going to take away -5, so I'm going to add 5, which is the same thing as take away a -5. I'm going to add that to y, take away -6, which is going to be y plus 6, squared, and that is going to give me the square of the radius, which is 64. All right, last question for question 3. So we've got a center at 3, -8. So the point is 3, -8. And that's our x naught and our y naught. And it says we have a radius of 3/2. Okay. So that means I'm going to rewrite my formula. X, take away our x naught, which is 3, square it, and we're going to add our y, take away a -8, which is y plus 8, square it, and that's equal 3/2 squared, which is 3/2 times 3/2. 3 times 3 on the top is 9. 2 times 2 on the bottom is 4. So we get, and this is because r squared is 3/2 times 3/2, which equals 3 times 3 is 9, and 2 times 2 is 4. Okay. So next we'll look at question 4, which is really just give the equation of the circle. So to do that, we're going to need to know the origin. The coordinates of the origin are 8, negative 2, and it looks like it has a radius of 2. So for question 4, it's a really similar question. I have a point at 8, negative 2, and a radius of 2. This is my x naught, my y naught. So I can now go ahead and write my equation. So I've got an x take away 8 squared plus y take away my negative 2, which is y plus 2. We're going to square that. That's going to be equal to 2 squared, which is the same thing as saying 4. So we're done there. All right, on graph paper, we are going to draw our answers to question 5. On graph paper, sketch the graph of the circle. All right, let me see. My graph paper. Yes. Haha. All right, so for question 5, we're going to sketch the graph of the circle. And I thought briefly about sketching all of them on the same axis, but I think just to keep it nice and neat, I'm going to do these all separately. So for question 5, we'll do A first. All right. So what do we got here? We have a formula that states that our origin is at 0, 0, and that's why it simplifies to x squared plus y squared. And we have a radius of 16. So it's the same thing as saying x take away 0 squared plus y take away 0 squared is equal to 4 squared. That means our our origin is at 0, 0, and we're going to go 4 in each direction. 2, 3, 4. That's our radius. And so then I can just draw best circle I can here. It's very difficult to draw a circle. That is not terrible without tools, but it is the mark of a great artist, which I am definitely not. So that is the equation x squared plus y squared equals 4. Oops, equals 16. Okay. Moving on, let's try B. Okay, so for B, all right, so looks like here I've got an x naught and a y naught. X naught, y naught of 6 and 8. So we've got 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. Oh no, I did not leave myself enough space. And then I've got a radius squared of 25, which means my radius is 5. Okay, so my radius is 5, so I've got to go 5 in the left direction. 1, 2, 3, 4, 5 to a point there. 5 in the down direction. 1, 2, 3, 4, 5 here. 1, 2, 3, 4, 5 here. And we're going to get some sort of circle. I would say this doesn't look great. Not my favorite circle, and I did chop it off a little bit, so that's a little bit of my fault. Now, a good circle has solid lines, not dotted lines. I'm just using the dotted lines as an aid, so I should actually go back and draw a nice solid line along this outline. That's more or less the way the circle can look. Okay, so we'll move on to question C, and I'll try to do some forward thinking with question C to make sure I've left myself plenty of space. So this says my x naught is equal to negative 1. I took away a negative and it gave me positive 1, and my y naught is a negative 5. My radius is 1. Okay, so it's actually going to be really easy to leave myself enough space here. All right, so my x value of -1 and my y value of 1, 2, 3, 4, 5. And my radius is 1, so I'm going to have a circle like that. Oh, gross circle. And that's x plus 1 squared plus y plus 5 squared. That's all equal to 1. And I'm looking and I'm thinking I really maybe could have drawn all these on the same axis, but actually no, there would have been a bit of overlap here, so maybe it's best that I didn't try. All right. So last question, D. Okay, so what do we got here? We have an x naught of -9, a y naught of 0, and a radius of 3, because this is our radius squared. Okay, so that means I'm going to make sure I've got lots of room in this direction. And, oops, a little room in this direction. And so I'm going to make sure I've got 9 in the negative x directions. 1, 2, 3, 4, 5, 6, 7, 8, -9. And so that's my center. And my radius is 3, so I'm going to go out to -12 and into -6. Down and up. And, oops. And you have the world's prettiest circle. Please make your circles look nicer than mine if you want to retain your self-esteem. Okay. And that's it. Those are our pictures here. So we're going to move on to some more in-depth questions here on the next page. Okay, so a circle has the equation x squared plus y squared is 12. And we know the point 2q is on the circle, so we're going to determine the value of q. Okay. So to approach this question, we need to know something that is, I would say, very fundamental to the idea of writing an equation that represents a shape in space. In other words, a relationship between x and y. This says that the point 2q is on the circle. And what it means for points that are on the circle is that any coordinate that is on a circle or on a line for line equations or on a parabola for parabola equations is a solution to the equation. And when I say that solution to the equation, I mean the points 2q are values of x and y that make that equality hold. That's a very important idea. So I'm going to do an aside here. Okay. So as an aside, let's take as an example one of our questions from question 5. So 5a. 5a, let's do a weird one. Let's do 5d. All right, so for 5d, I've got the equation x plus 9 squared plus y squared, and that equals 9. Now what that says is that there's some pairs of x and y that if you add 9 to x and then square it, and then you square y, they're going to be equal to 9. And if you can find x's and y's that make this equation on the left-hand side equal 9, those are all of the points that make this shape. So I'm going to pick one of these points randomly. Now it looks like it might pass through certain points like here, but it doesn't actually. So I'm going to pick one I know it hits, which is, I can see that it hits the point -9, 3. I can see it hits the point -6, 0. I can see it hits the point -9 and -3. And it hits the point -12, 0. So I can take any of those points as my argument, put this at -9 in for x, say, and -3 in for y, and find an equation that equals 9 on both sides, gives me something true, tells me that this equality holds, that I can have an equal sign between them. It's a very deep idea about algebra. Okay, so I'm going to choose one at random. I can choose any of them. I think I'll choose this one because to me it looks the weirdest. In every way that I can think of, it has something odd going on. So let's just see what happens. I'm going to put in my -9 for x and my 3 for y. These are paired points that supposedly are going to give me 9 when I crunch the numbers. So let's see. X is -9, so I'm going to put -9 plus 9 squared plus my y value is 3 squared, and that's equal to 9. So is this true? Does this give me truth, or does it give me something false? -9 plus 9, that's 0 squared. Plus 3 squared is 9. And I can see I get 9 is 9. That's true. And I can do that for any point on this curve, not just these 4, but if I could find the precise point here, and I knew what it was, I don't actually, but say I could, I can think of a few ways to do it, I could also put those values in for x and y, and they'll give me 9. But if I choose another point that is not on this curve, let's just prove this is true. I'll choose, say, this point. What is that? That's the point -7, 0. So I'm going to try that as well. I'm going to put that in and see what happens. So I'm going to get -7 for x plus 9. Square it. And I'm going to put my y value of 0 in. So I'm going to square 0. And that's supposed to give me 9. All right, so does it? -7 plus 9. That's 2 squared plus 0 squared equals 9. And I get this weird statement. I get 4 is 9. That's not true. It's false. So, in other words, because this is false, I can make a conclusion about both of these. If this gives me a true statement, I can say, therefore, the point -9, 3 is on the circle x plus 9 squared plus y squared is equal to 9. However, I can also make a conclusion that the point -7, 0 is not on the circle x plus 9 squared plus y squared equals 9. Now, this is not new. You have seen questions of this sort in line geometry in grade 10 and with parabolas in grade 11. This is not a new concept, but it may need some refreshing. That's why we're refreshing it right now. Okay, so if I have a circle with an equation like this, I'm told that the point 2q is on the circle. That means this x value of 2 and this y value of q are such that if I put them in for x and y, it will give me something true. So let's see what happens there. So if I put x in as 2, so for my x squared plus y squared, and it's equal to 12. Okay, I'm going to put in my value of 2 as x, so I'm going to say 2 squared, plus I'm going to put q in for y and get q squared, and that's equal to 12. So q has to take some number so that it gives me an equality, because I know it has to. The point is on the circle. That means that 2 and q are solutions to this equation. They're going to give me truth. Okay. So I'm going to try to find q. I'm going to use algebra to do it. And then I'm going to come back. I'm going to prove that the point 2q does give a solution to this equation. All right. Okay, so first I'm going to simplify. So it says 4 plus q squared is 12. Okay, I'm going to take 4 from both sides. That gives me q squared is 8. And then I should probably square root, principal square root. Or is it not principal? I always get that mixed up. Okay, so anyway, I know that gives me q is positive and negative root 8. Now root 8 can actually be simplified because 4 goes into 8, so I can say it's plus or minus root 4 times root 2, because that gives us root 8, which is another way of saying q. The same thing as plus or minus, 2 root 2. Okay. So q could have two values. It could have a positive 2 root 2 or a negative 2 root 2. All right. Now, let's just make sure that makes sense. I can punch it in for y, but I'm not going to right now. First, I'm going to graph our original function. It has a radius square root of 12, which means the radius must be the square root of 12. So the radius is about 3.46. So it's got a center of the origin, and it's got a radius at like 3.5 almost. All right. And that's the point 3.5-ish approximately. Approximately 3.5, 3.46, dot, dot, dot. Approximately negative 3.5. Approximately negative 3.5. Okay. Does it make sense that if my x value is 2, oops, 2 is like here, that my y value is 2 root 2, which is 2.8, 2 and 2.8. Yeah, it kind of makes sense that we're in the right neighborhood. Okay. But more importantly, I'm going to take this value and put it back in for y. I'm going to prove that it is a solution. So is the point 2 root 2 on x squared plus y squared equals 12? So I can test that by putting x and y in. 2 squared plus 2 root 2. This is a case where actually, shoot, I forgot to talk about the negative. We'll get to the negative in a second. Okay. So I'm going to actually think of the root 8 instead of 2 root 2 for now. I think that might be more simple for me. So root 8 squared. They're equivalent. You can choose which one's simpler. Okay, is this true? Well, let's just check. 4 plus square root of 8 squared. Those are inverse operations. So they cancel out. And so we get 4 plus 8 is 12, or 12 is 12. Is that true? Yeah, it's true. So therefore, 2 root 2 is on x squared plus y squared equals 12. We're going to go through question 7 much quicker, by the way. Now, however, we did have the second solution. We had q is equal to 2 root 2 and negative 2 root 2. Now we can see in our diagram that it kind of makes sense. We can have a point at 2 root 2, and negative 2 root 2, because the circle seems symmetric, is not a function. Let's just test that. Is 2 negative 2 root 2 on x squared plus y squared equals 12? Well, let's just test. We can test that too. So I'll just try it. So I'm going to replace my x with 2. So it's going to be 2 squared plus my negative 2 root 2, which is negative root 8 squared. Is that equal to 12? Let's just check. 2 squared is 4 plus negative. Okay, so I'm going to square this. So negative root 8 times negative root 8. Negative times a negative is going to be a positive, so it's going to give me a positive value. Root 8 squared is root 8 times root 8 times root 8, which is root 64. And root 64 is actually just 8. So I get 12 is 12, which is also true. This gives us truth. So that means, therefore, 2 negative 2 root 2 is also on x squared plus y squared equals 12. Okay. And so our answer, Q, is 2 root 2 and negative 2 root 2. That's our final value. All right. That's a pretty key idea. So I'm going to stop there. I'm going to do question 7 and 8 on a separate video. Let me know if you have any questions about any of these.